So yeah, just to kind of reiterate, since I just started recording, and like the takeaway here is, I mean, this is the big takeaway. Fixing bugs in software it really is insanely expensive. Bugs are expensive. And, you know, Carlos is going to just drill that in, and he's right. Like, and, you know, they are unavoidable. It's just, it is part of the software world, or I should say software world. But, you know, as a developer, and definitely as you start getting into production, you know, levels of applications, you really want to, you know, have that be in the back of your mind. And, you know, especially this integration part and this pre-deployment part, that's kind of where like the QA comes in. You know, development, I'd say this is where your probably your unit tests can come in. You can find a lot of bugs with your unit tests within this development section, and those are cheap to write. So I think most places, you know, that's probably pretty common to, you know, have a couple of unit tests, you know, before you like push to master. And then integration tests, these get harder to like automate, but you might do that as well. And then pre-deployment, yeah, you might just have a QA team who either manages the code to automate the testing, or they manually test it. And then, yeah, here's our three basic, there's more kinds of tests than this, but we have the unit test, integration test, UI test, or end-to-end testing. And you can kind of just think of this as we go up this pyramid. It's about integrating the parts of your app together. And also as we get up this, it's more hard to integrate, it's more hard to test, it's more expensive. And that's why we don't write as many of these tests as the other ones. So cool. Let's go ahead and get started with actually writing some tests. So I'm going to first, before we get into like the notes, let's just first take like kind of a naive approach of testing. So I'm going to cd into my directory. I made it 10 directories, week 10. So I'm just going to create a file called test basic.js, and I'll just open this up in VS Code. Now, what am I doing? Code dot. Okay, so let's just keep this simple with our function. Let's say I have a function, basic add function. Let's say I want to test this. So let's look at testing and how we've been doing it. So one way I could test this is just do like a console dot log, add. So that's kind of how we've been testing things, right? Maybe store it into a variable, we log it to the console, and we like visually check. So what's kind of wrong with, or not wrong, or what's kind of bad? What's kind of like a con of this way? Of doing things.
Maybe it's not like real world data, it's just stuff you're making up to fit what you need.
Yeah, I mean, that's like, it's, yeah, is that real world data one-on-one? Like, I mean, I guess like this is a simple case, but yeah, maybe I'd want to test something like, I don't know, like a big number. And yeah, maybe like a negative number, like a decimal number. So yeah, there's stuff like that. Like, is it real world data? Is this how I'm actually gonna, like, how am I actually gonna use it in my app? So I could kind of think about that, and then maybe I want to like have some bigger numbers, and now I'm testing it. Maybe I want to test negative numbers. So what's kind of going on here though now? Now that I'm, doing a little more testing, what's going on now?
Do you really know which line of output was connected to which line of like test?
Yeah, that's getting it's getting a little hard to read now, right? Because now I have this one function, and I've written 4 tests, and now it's like, well, is this right? How am I, like, let's say someone, and I know this is a simple example, but let's say plus this add function is really hard, but let's just say someone accidentally comes in, or not, for some reason they make that a minus. It's maybe a little hard to tell that this is just by looking at the values and looking at the code. Like, we can do that because we're very familiar with the add function, but how can I be sure that, this is working, that those numbers match just by looking at the logs? So that's kind of, getting a little already just with one function and just 4 tests, getting a little hard to read. If we're also talking about testing, where we're trying to maybe break stuff a little, what other things might I want to test?
Like what would happen if you put a letter?
Yeah, sure, that sounds good to me. Like, what if I give it a string? Now, I don't know about you, but I don't think my add function, because this is like a math add, should return this. So this is the other thing. So when we're writing unit tests, the whole point of writing tests, it's like, you really, when you're like putting on your test hat, you want to like break your code. You're trying to think of cases that might break your code. And so, yeah, throwing in a string you know, that might break it. Because when we go look back at like this part or this graph, because maybe I'm developing this add function right now, and maybe I think, oh, let's see what a string does, and it breaks my function. Now, I might not know what to do about that. And like, maybe I have to go back to like the designer or the architect who's designing this app, who's in charge of the app, and then go ask them, hey, we didn't really think about this beforehand, but you know, hey, I came up with this test where I gave it a string and it breaks the add function. So what should we do about that? So you might have to redesign, you know, that your feature and be like, okay, you know, where like maybe beforehand, this was just like, you know, should add 2 numbers. Maybe that was like the initial requirement. But after finding this bug, we go back, we kind of update it and be like, so this should say this. Take 2 numbers and add them together. And then, you know, later we have like a revision. Revision. If either number is not a number, I'll return Nan. Because the other thing just to keep in mind, like with the design part and the like gathering the requirements, we're, you know, most software companies, as Nee talked about, are going to use an agile development where we're not going to do that waterfall process where we're going to get all the requirements and, you know, design up front. We do want to get as much as we can up front, but you know, software world's very flexible, very agile. So we need to be able to like pivot at these points and kind of go back and forth. Because while you're, I mean, I know this is a kind of silly example, but just to keep it basic, because maybe when you first designed this and you got the requirements, that's what the, you know, the people or the designers or the architect, they thought of. And they didn't really think about this edge case. And now they did. So it's like, oh, let's redesign this. Return Nan. So then you can, but you know, we could say, hey, we caught this like in the development cycle. Because, you know, this potentially could have been, you could have said what someone entered as character, but what if someone entered, you know, a number or like a string that was a number? That's 11. That could potentially, you know, this could be a big bug. We'll kind of look at that one. Because this could be one like, yeah, like I said, if you were just kind of doing the logs, you might see that, you might not notice that this 11 is actually a string and that it was actually trying to add, you know, 1 and 1. And then let's say this was like a banking app, you know, that got pushed to deployment. And, you know, your add function was responsible for adding, you know, incrementing someone's bank account. Like they're changing their balance and they deposited like $1, but instead of $1, it would just append 1 to the front of whatever their balance was. So if this bug got out to production, that could be, you know, one of these really expensive bugs. But we found that in development, and now we're going to redesign it. So we could do something like this, just to kind of show you. We can use the type of operator. See, that's a number. I could do type of 1. That's a string. So I could just do a little check here. I could say if type of num1 is not equal to a string, or type of num2 is not equal to a string. Return Nan. Now it's returning all of them as a string. Okay, what?
Because you have, if num1 is not a string, then return Nan. You need to switch your returns.
Do I need to switch my returns?
Because if it's not if both of them are not strings, then we want to do the math. If one of them is a string, then we want to return not a number.
Oh, I see what you're saying. Okay. If I just need to make that equal. If that so if num1 is a string, or if num2 is a, oh sorry, I wanted to do it this way. If it's not a number. That was what I was thinking. That's the way I want to do it. So if either of these are not a number, I'm going to have them return down. There we go. So now I'm catching those two cases. And then when someone uses this function, like I'm just going to like leave that in the notes. You know, this expects 2 numbers. If you don't give it 2 numbers, it returns Nan. That's just how you use this function. Or I could like throw error. New error. How do I need to Google this really quick just for the syntax. This can be another way. You can kind of do like, just kind of do a little side note here. We could throw an error. Not give a number. Is this how I can do it? Did I not spell throw right? What's the error? Throw did not give a number. Or is that the error? Well, maybe I'll get this when we get into the testing library. I think it is throwing the error. But well, let's see if it is throwing the error. I'm going to comment these two out, or if it's just the syntax error. Okay, yeah, so that works. On that one. Yeah. So I can actually cause an error to be thrown. But when we get to testing, we'll maybe look at how when we test that, we'll kind of look at that. For now, I'll just return Nan. So yeah, this is one way we can start testing it. We thought of like one edge case. I'm sure we could think of some more, but let's kind of keep it just like this for now. And then maybe think of another way we can maybe make this a little more easy to test. So one thing I could do is I could just write this in a function. This test add. So I'm going to write this in a function, and I'm going to do, I can do stuff like this. I can do like sum1 equals add 1 plus 1. And then I can kind of manually come in here and I can do stuff like this. Because another thing when I'm testing, because down the road you might have thousands of tests. So I don't need to see logs for all the tests that passed. You know, I might just want to see where it failed. So something I could do is I could come in here and, you know, start writing just a test add function where I have a whole bunch of if statements. Or I could say something like this: I expected, you know, 2 got, and I could even leave myself a nice little message that tells me what I expect, where I failed, what I expected, and what I got. So let's do a couple of these. Kind of keep this a little small, just so it's kind of easy to see. You know, we 4 plus 4. You know, that equals 8. Then, you know, I could try my sum 3, where I could try a number. You know, I could maybe even come up here, do like a past Boolean. I'm going to set that equal to true by default. I'm going to make this a let because I'm going to change it. All of these, I could say like past equals false. Return past. So I'm going to get rid of all these console.logs. So now I'm coming in, I've written a function to test my add function, where I'm now giving myself, you know, some more, I'm giving myself some meaningful logs if I do fail. And then this test add functions, you know, I have this Boolean of past. I'm just assuming it's true at the start. And then if any of my tests fail, I'm going to set past equal to false. So then I could, like, you know, run this test add function. And, you know, I could throw this in a statement. Expected Nan and got Nan. Oh, wait. Did I have this? If sum 3 does not equal Nan. Is this one of these weird ones? Nan's kind of a weird one. Try this node. Equal Nan. Yeah. There you go. That here's a funny thing. Nan does Nan equal Nan? That's false. Nan's a little strange in JavaScript. I don't know how we do type of Nan. Oh man, I don't even know how to check for this. So here's just another thing about testing. You can write a test where you think it's going to work, but it's broken. And you're not going to like run tests for your tests, but that makes a lot of sense to say like, you know, I'm expecting Nan here. So does Nan equal Nan or not equal Nan? Then I'll fail, but it's a little random thing with JavaScript, not a number. If I say does not a number equal not a number, that is false. So let me, that's something I'm gonna have to Google. Check. So there's the is Nan method. So I'll go ahead and use that. Just do that here is Nan. That's a function. So I can throw in Nan there. What? Oh, I spelled it wrong. Is Nan. Nan. So yeah, that's just a little side. Your tests are only as good as you write them. So if you write a test that has bad logic and it fails, then well, you gotta be a little careful with that. That still is Nan. Oh, I need to do a not here. If sum 3 is, I'm expecting this to be a Nan. And it's not. So there we go. We have my test. Test add has now passed. And you know, if I'm testing my add function, I don't. If all these tests are passing, I don't really care. I just want to know that I can run this function. I know here I can just add a whole bunch of cases to test this add function. And all I really want to see is, you know, this, that it's passed. But now if I come in and I switch this to like a minus, let's say that happens like, because here's also the nice thing about unit tests is I wrote these and now I have these. I have this function test add where now I can run this anytime. So let's say like a month later, someone comes in and changes this function to get their code to work, which, you know, happens all the time. And then they go in and run the test. Now, all of a sudden, they're getting some, it's letting them know it failed. And then it's also giving them some messages, you know, failed at add 1 and 1, expected 2, got 0. Failed at add 4 and 4, expected 8, got 0. So it's going to tell them where it failed and what they got. So we're getting some nice messages. So this is a better way to do it than just console.log. I mean, I'm still using console.logs, that's fine, but I have it set up in a way where now I'm only logging my failed cases. And then I'm also giving some information about, you know, where and why it failed. Because this is going to really, you know, help you debug. Because then you can see the exact edge cases where it failed. And that can help pinpoint to you, oh yeah, that's a minus, that should be a plus. Cool. So now what do you think, like, so doing it this way is definitely better, but what's kind of, or what can you kind of start to see happening here with this? Like if we were to do like a minus function, a times function, or we wanted to add more edge cases, wouldn't a lot of the code start to look the same? We might do like a test add, we might have like this let past equals true. We might come up here and do all this and all this if statements. So what, and we're not going to do this, but what do you think you would start to do? You probably start to take a lot of this stuff and start building functions to, you know, clean this up a little bit and reuse some code. But testing is so common, in any language that you use, they're going to have like testing libraries that kind of do some of that for us. So, and they're also going to, I think one other issue with this that, you know, since we haven't done testing is a little harder to tell, is I think this is not, it's still a little unreadable. Like our tests are kind of hard. I think it's kind of hard to read this. So let's go look at a testing library called Jest. And Jest is going to help us do this. It's going to help us test. You know, it's going to help us with unit testing. And it's going to give us ways to write some tests that are readable and, you know, give us all this nice information about where things failed out, what we expected, and it's going to run our test for us. So let's do that. I need to find the repo that we're going to clone. Give me 1 second. So I'm just going to be, let me give you this repo 1 second. So I just threw this repo out in Slack. We'll get it set up and make sure it's working, and then we'll take a little break. So for this, and then also I'll throw out the command to clone it. Throw this in Slack. It's just going to be a git clone, and just copy the SSH link. So then we could CD into that. Just starter. Run yarn. Cool. Let's open this up in code. All right. I'm going to close this one too. Okay, so we have this open up in code. So notice here we have two folders. We have a source folder and we have a test folder. So in this test folder or source folder, we just have an index.js where we have a const test string, which is just a string test string. Then we have a function that's a test function, and it just returns that variable. And then in the test, we have a file matching the name of this file in our source. And we just import the function and the string from, this is like really simple, just importing those. And then what I can do is I can get the result from my test function. And I do this it statement, so it returns test string. So one of the nice things about Jest is, and what we'll see this, is it becomes very readable. So I'm describing a test like it returns test string, and I should maybe just write that as a string. And then here's my actual test right here, where I can get my expected and I can grab the result. So I'm expecting the result to be the expected value. I could also just simplify this and get rid of that. Or I could even just further simplify that. I guess we can leave it like that. So I run my function, store that in the variable, and now I have this expect result to be test string. And then I can come in here and run yarn test. And there we go. We have it runs the test, it's saying it passed, and then it's giving me this like green, hey, this is passed. If I were to like change this to be, something else. Now it fails. Get this nice message. So I expected something else, received test string. And it's letting me know right where this failed. So cool. If you got up to here where you can run yarn test and you can change that back so it's running, and then we'll look at this. Let's take a break. What time is it? Let's come back at 10:45. If you're not here or you're having issues, I can stick around for a bit and help you get this set up. Any questions on this though so far? Cool. Hey, camera off. Cool. Oop, I'm not sharing my screen. Or am I? Am I sharing my screen? I am. Okay. So now that we have this set up, let's actually go write some tests and kind of look at what Jest gives us. So let's just go ahead and since it's fairly straightforward, just go rewrite our add function. So we could do if we're keeping it, we could just do it as an ES5 function. Just to practice some different syntax. Export function add 1, 2. And yeah, we can do our if num1, num2. If type of num1 does not equal number, or type of num2 does not equal number. We can return Nan. See, this time I am, so I'm going to just comment this out. Well, let's just do this for now. Let's do this. I'm going to, for this one, I want to throw an error. But I kind of want to more like talk about invalid. Oh my God.
ID, not E.
Wait, dude, I'm having like
Just take out the E. Take out the E and put ID.
Okay, I get it. Dude, it's amazing how like coding has, I was already a horrible speller, but coding has made it worse. Okay. Let's just talk. I mean, this is less about testing and more about code. Why? I mean, what's the difference between, so if we're doing this check right here, where we want to, like, we just want to make sure that who's ever using this function is giving us 2 numbers. So we could do a couple, I mean, we could return undefined, we could return Nan, or we have another option of throwing an error. So we can just do this here for now. So what's the difference? Why would we want to choose one? Or I don't want to say one's better than the other, like, especially for this case, it's really case dependent. It's kind of more the why we would choose one way or another. So if I like run this code, let's just do like, say like for some, we have like a let sum equals this, and let other sum equals, console.log other sum. And then we'll also just like log done. Okay, so let's pretend, pretend someone, like this is a coder probably on your team. Is using your function wrong. So I can just run this. And let's, I guess for now, I'll have this return Nan, just to kind of show the difference. So let's first have this return Nan. So node index.js. Oh, it doesn't like this export. I'm going to delete these because we don't. This works. Oh, sorry. I need to go node source index.js. Okay. So someone's using our function wrong, and then I'm just having this function return Nan. So what I'm trying to show here is by returning Nan, they can still call my function. They can store that to a variable, you know, where they can do math on it. And so when they, you know, come down here, they're logging other sum, you know, Nan plus a number is 2. So it's just gonna 2 plus Nan is Nan, and then it's gonna finish. So it's just done. Now it is doing some checking, because like if we do return, it is doing something. Because if I don't have this checked, you know, then it's returning this, you know, 112. Because it's adding 1, it's concatenating 1 and 1, which is 11. So now sums a string. So 11, the string 11 plus 2 is going to be the string 112. So this check does do something, and like at least it's returning Nan. So that's probably going to be easier to, you know, see something's going wrong. But the point here is when it returns Nan, my code is not breaking. Like it runs, like we're saying done. We're getting this log. So that's one option. Another option, you know, to handle this is just to return Nan or undefined, and then work with that. Another way you could do this is we can actually create an error. We can throw an error. And there we go. And I can throw like, there's a couple different syntax. I could just like throw invalid args. Or I could do like a new error and then wrap that string in there. But what I'm doing here is I'm intentionally crashing my app. So I throw the error and we just crash. So we don't see these logs because our code is going to stop right here because I threw an error. So, you know, you could think, why on earth would you want to do that? So can you think why I would want to do that? Throw an error.
One, it's probably easier to see where the error is occurring if you're like stopping the app as soon as that error occurs, but also you're not going to perpetuate an error further through the app.
Yeah, that's kind of exactly it. You can kind of, it's you're going to see where the error is occurring, and it's definitely going to alert you to it, to like, oh, something like this should not be happening. Like because my add function is really expecting 2 numbers. So by throwing an error, we're going to catch it right. We're going to see it happen right when, you know, it occurs. And so it's not going to propagate down into like this other sum where, you know, later in my code, I would just really expect sum to be a number. I mean, it's even saying like when I hope it's like it's a number, but it's really not. It's going to be a string because I use this function wrong. So it's kind of going to save me. So there are some language like Java, not JavaScript, Java, they kind of have a mindset of, you know, fail early. They want to like throw errors early. So you have to like, so you find them easier. JavaScript's a lot more forgiving. JavaScript, you know, is kind of a little more like, hey, let's just kind of let these errors occur, or like let stuff like this happen. Like JavaScript allows you to like add with math strings and just concatenates it automatically, which is nice. So the trade-off there is, you know, these errors do just stop your program. But with JavaScript, you know, it might not crash your app. So you can still like use the web page. And that's kind of like JavaScript was designed like that. They didn't want like a little, you know, error that you couldn't find some DOM element to style it green to just completely break your web page. So that's kind of the trade-off. You know, these throwing in errors are going to like quit your app. So
Is that what it means when it says JavaScript is weakly typed?
no, what it means by, so you know when we talked about TypeScript,
Yeah.
that's what it means by weakly typed. TypeScript is strongly typed. So TypeScript is a typed version of JavaScript. But I mean, in this specific case, if we were using TypeScript, you know, another way I could do this is I would say, hey, that's a number. Like
I guess that's a little more what I meant when I said like with the string 1 adding with the integer 1 being like not being like the types mattering less, I guess you could say.
Yeah. And that's one of the ways that JavaScript is kind of a little more loosey-goosey, is it doesn't have type safety. But I mean, there's other ways. For example, like with JavaScript, if you have an array, this is just like another example, like 1, 2, 3, and you try to grab like X at like 5, that's just undefined. In Java, that would break, like that would break your code. You get it like an array out of bounds exception. So JavaScript's just saying, oh, okay, you can try to grab that, but there's not that many elements. I'll just return undefined. And yeah, another way, like I said, with TypeScript or JavaScript, it doesn't have typed languages, because a type language would catch that too. But JavaScript by default is not typed. So that's what loosely typed means. So cool. So now we could, if we throw an error, now we have the ability to catch it. So just because we throw an error doesn't mean our code has to break, because what we can do is I can wrap this in a try catch. So I can try to do all this stuff. Let's see. Where is that? Did I not save that? Try. That should be catching that. No, source index.js. I swear I just did this. not like this new error. Isn't like the new error. I need to go check why that new error, why it doesn't like this. Can I throw in the type there? So I can just throw an error right here. And that's, so if I wrap this, I need to go double check why it doesn't like this new error in the try catch. I thought they were, honestly, I thought they were the same. But so if I get rid of that and just throw the like invalid args, that's now what, so I can try to do this and I can catch it. And then I can handle that, you know, here. So like for in this example, if I was getting user input, I could like re-get numbers. Let's say this time around, I like get actual good data. So someone could try to do something bad, then I could catch the error. I could re-get the numbers, add, and then do the math. So just because I throw an error doesn't necessarily mean it has to break my app. What I can do is I can catch that error, you know, maybe then give the user or the coder or whoever some, you know, UI or something to like, hey, you need to like throw in a number here, and then they could redo it. So yeah, I'm just gonna throw this in here just for myself, new error. This. Just a message from me. Okay. So there's our, and you know, we've been using try catch blocks. So you can think, you know, with Axios, they resolve or reject. The reject throws an error, but we can write our own errors and then we can handle them. Cool. So we'll kind of look at that, but let's kind of look at some more testing with Jest. So we'll also test with like throwing an error with Jest. So let's go now write some tests for our add function. So we have our add function. Let's go to our tests. I'm just going to get rid of this. Let's go to our tests. Okay. So let's import our add function from, and I need to make sure I export this. So we can import add from our source. So we need to go back a directory and then our index. And now I can start writing my test for Jest. And so with Jest, you can use an it. We can also use like a describe, just kind of do similar things. So we can describe what the test is doing, like it adds two numbers, because that's what our add function does. And we're going to see these messages will come up in our logs. So it's one of the nice things about Jest is it makes our test very readable. So for my describe block, I put in a string just describing what I'm going to be testing. And then as my second argument, I'm going to pass this a callback function. So with jest, this is really where you want to like, there's going to be a lot of callback functions. So I highly recommend you really stub these out and then you hit enter. Because then inside of here, I can run like specific tests. So I'm doing a test with, adding 1 and 1. And then boom, I'm going to write another callback function. So then I can do expect statements. So I'm expecting my add function dot to be and now I can run this just by running yarn tests. There we go. I've had one suite and that has one test inside of there. Right, another test. So this can still be all within this describe block of, my adds 2 numbers. So I could do 0 and 0. 0. It adds. So another thing you might like in this description, like I don't have to say exactly what it's doing. I could say something like this: it adds big numbers, because maybe that's what I'm testing here. I want to make sure my add function can handle big numbers. So sorry, I need to expect. So I'm going to use this expect statement. So things like, so I should say this describe, test, expect. These functions are defined. These are what jest is giving us. We don't need to import them just because of how this is set up and how we're running these tests, and it's in like this .test.js file. So it's like when we run yarn test, it's going to know, like it's just going to know where to grab these functions. So I'm going to expect, let's just go ahead and add 10,000 plus 10,000. I'm going to expect that to be I can run this. I might want to say it adds negative numbers. So this is where you can write just a lot of tests. You can kind of test these edge cases, like does it add big numbers? Does it add negative numbers? That kind of thing. It adds decimals. Right. Actually, let's look at this one. 2 plus plus 0.1. This is so I'm just writing a couple tests. I think this is all working. I don't know if you saw that last one, Phil, but so it's kind of a little bit of a trick question or kind of giveaway. But is my add function working? I mean, I'm testing all of these. I'm getting them all green. Looks like it is. This is like a very, very rare edge case, but
Is 0.2 plus 0.1 something like 0.300004?
yeah.
What about that one?
Yeah, so this one is actually, this would be an example of, I mean, when you look at this, it looks correct. Like this test looks good. I mean, I'm expecting that to be, I'm adding these numbers. I'm expecting that to be 0.2 plus 0.1. That really makes a lot of sense. But if I switch that to be 0.3, that's what I'm really expecting 0.2 plus 0.1 to be. All of a sudden, this fails. And so, yeah, we get this, we expected 0.3, but we really got this really crazy number. So, and maybe I'll have, and like I said, this is kind of a, yeah, kind of a weird thing with binary, but yeah, had I written my test case the other way, I would have think this would have passed. But it's also just another one of those things like, am I just supposed to go through and test every combination of decimal numbers? Because, if I do like 2 plus 0.3, expect that to equal 0.5. That works. I'm still just failing on this one. So a couple takeaways here. First of all, your tests are only as good as you write them. And yeah, you can test, till the cows come home, but you still are probably going to miss some cases. So this one is really, it's just a issue with adding decimals. There's a couple decimals, like, because remember at the end of the day, everything's converted to binary. And when you convert these numbers to binary, like you just can't represent them in binary as 0.2 and 0.1. Or you can't, I can't remember it's 0.3, but 0.3 might be like a repeating number in binary. So you don't get 0.3, you get this representation of it. So I'm not gonna. So yeah, if you're doing like really sensitive stuff with decimals and you're having an add function, you might have to like come up with a way to fix that. I think that's beyond this lecture today, but just note that's a failing case.
Could you Slack out your index.js, please?
Yeah. So yeah, I'm just going to comment that out. Let you look at. I know Derek. He's a dev at DPL for like the dev side of things. He ran into this issue where he actually had to come up figure out how to solve that. I mean, there's definitely libraries that will help you do that, because this is not just a JavaScript thing. This is a binary thing. So say it's going to be true with every programming language that it can't do that math. I think that there's a couple other ones. I can't remember them, but there's a couple other decimals that you can't add to be a whole decimal. But we'll kind of ignore that. But it's kind of a fun little side note. So let's do this. Let's try to handle that that throw case. So let's do our test of that. It handles valid input. So I could expect, add 1 and 1 dot to throw. And I think I can just throw in the name of the error here. So I just match this.
You never pasted the file in the Slack. Or maybe you didn't press send.
Oh, I sent it into the wrong channel. Sorry. Thank you. Into the summer 20 to delete that. Okay. Sweet. Okay, so this one I'm going to run. I think this is going to break. So this one's saying, so I can when I look, let's just kind of look through these. Once again, it's one of the nice things about Jest. So it's giving us this nice little message. So it's showing our tests that are passing. And then I'm getting this, it handles invalid input. So that one's failing. So this one actually, something with a throw that we need to do is I think I need to throw this. If I'm expecting something to throw an error, I need to just wrap that in a function. And that works. So just a little different syntax. I throw that into a function, so that will throw the error, and then that will equal that. So now that's passing. Cool. And now my tests are more, like I said, Jest gives us this framework to make these more readable tests. This is, describe, it adds 2 numbered test, it adds 1 and 1, expect add 1 and 1 dot to be 2. So it's very readable. And then if these fail, let's just make these all, or some of them fail by making this minus yarn test. It goes through and it's telling me it adds 2 numbers, it adds negative numbers. And then it's telling me what it expected, what it received, and it's kind of showing me where it's failing. So it just gives me this nice framework to write tests. So cool. Let's also see like another benefit. So let's do this. Let's go in and let's make a new file. Let's just call this I don't know, just demo.js. So what can happen, like what you can imagine this happening, you obviously can have tons of different JavaScript files. So I could do something like this, you know, export const. You know, let's just do something like let's do a divide in here. Let's just do it. Let's kind of just do this. Let's just do for now num1 turn num1 divided by num2. We're just doing a divide function, just kind of simulating like, you know, we're doing something else in a different file. Now you can imagine that like in this index.js, you know, I have like 20 functions. In this just demo, I have 20 functions that I'm all testing. But it just gives me this nice framework to a nice structure to kind of test these. So if I have a new file, I can just create a new test file. What I'm going to do, I'm just going to rename the file, my test file, the same name, but I'm just going to give it the extension .test.js. I can import divide. You know, source just demo. And then I can start writing tests for this, you know, function. So I could like from a different function, from a different file, you know, write this test, like expect you know, divide 1 and 1 dot to be 1. Divides large numbers. And then I can come in here and I can write like a lot of tests. And now, to run them all, so just you could imagine I have like, you know, 20 different files, each have like 20 different tests. And I want to run them all. I just run yarn test. So now it's telling me, hey, you have 2 suites, so these 2 files, and we have 8 tests together, and they've all passed. And you know, I really don't, if they're passing, I really don't need to see anything else. I just need to make sure that, you know, all my tests is passed. And what will happen, or what will become part of, like if you're at a place that uses test and uses unit test, before you like push or do a merge request, you're not going to be able to do a merge request unless all your tests pass. I mean, this is like kind of like the basics of testing, but it's kind of why, and all languages are going to have like a testing framework. And the point here is they're going to make this a lot easier to write all these tests. So hopefully you can start seeing, I mean, even with something like add, we can think of a lot of edge cases to test this. But the nice thing now is once we spent the time to write these unit tests, now we just have them. And now they're kind of there with our code project forever. So if you're working at a place who's been doing testing from the beginning, they might have like honestly like thousands of tests that run, and it can take a couple minutes to run these. But it's just a good way, like, to make sure you're not breaking any of these individual parts. And, even with unit testing, it's very likely, it's not that they're always going to be isolated, like, does that work from index? You definitely might have a function where you're using multiple functions. So use that add function. And then you. So we're doing unit testing, but your unit testing, there still might be definitely some integration with that. Because in code, you're definitely, even your small unit function functions are still probably going to be using a lot of your other functions. But let's do something like this. So I have an add and divide by 2. So just, let's just say for some reason, I'm purposely adding a bug because I'm dividing by 3 right here. So I have some, let's go write a test for this. So I'm just going to copy this because it's going to be a lot of the same code. Add and divide by 2. Let's add and divide by 2. So we'll do, we'll expect 2 and 2. So that'd be 4 divided by 2. I'd expect that to be 2. And let's just get this working first, and then we'll break it. Oh, sorry, I hard-coded 1 and 1 in there. Number 1, 2. Okay, so this is failing. This works. So something just to like use our imagination, like everything's fine and dandy. And then for some reason, like a couple of weeks later, someone switches that to a 3. And then we run this test. Now, let's not pretend like this is so simple that we know what this is doing and we know what this like num divided by 3 is doing. Like we know that our test is failing right here. So what this is going to have us do as a developer is, well, I need to go check this and add and divide by 2 function. So I would come in here and check this function out. Now, if I had been doing unit testing and like have built this up, because I might ask myself, is it wrong here or here? Those might be two places I might look at. But if I went and looked at my tests, I'd be like, hey, all of my add tests are passing. So this looks like it's good. So there must be something wrong here. So then that it's going to help direct me when I'm looking at the function, where is it broken? It's going to be like, oh wait, since I, tested my add function and none of those tests are breaking, it's probably somewhere around here. And then I think, oh yeah, I need to divide by 2. Then I can run my test and those are passing. But if my add function was like, let's break my add function and I run my test, I would then go and see like all of my add functions are failing. So when I looked at this, then I'd be like, well, gosh, all of my other add functions are failing. So it's probably something wrong with that function that is causing this test to fail. So then I'd want to go change my add function. And by fixing that bug in my add function, it would make this test pass. So these tests can they give you a little sense of, confidence, that the inner functions that you're using in your functions are either working or not working. Cool. Let's do this next. What time is it? Let's kind of go through. So this is going to just be more on, and I'm actually just going to do this in a test file. So we kind of saw how we could write functions. We can import them into our file and test them, but let's just kind of look at some other things that Jest gives us. So what I'm going to do, actually, I'm just going to do this right here. Okay. So I'm going to come up here and just, I would normally do this in another file, but just so we can see it, let's do this here. So we're going to create like a can. So this is going to be name. It's going to be, and then ounces. So I just have a JavaScript object right here, and that we're going to use to test. So I can describe, it's like use some Jest stuff to talk about this can. So test. It has 12 ounces. We could expect, can dot ounces. I'm writing this wrong. Writing Jest will get you really good at writing these like callbacks. Because we have a callback where we're writing all this stuff, and then in that callback we have a callback. So expect count dot ounces dot to be. So we've talked about this expect to be talked about the expect.toBe, but there's going to be a lot of these matchers. So we'll look at some of them. So we're describing the can, it has 12 ounces, you know, it has a name. So we can expect that this object, you know, has these fields. So we could also test it does not, you know, have what is something does a Coke not have? It does not have diet flavor. Whatever. It's something it doesn't have, it doesn't really matter. So I can do this. So I can expect can name dot. So I can use a not to be diet. So I can use this to be matcher, but I can also negate that. So if I want to check that it's not something, pretty straightforward, can just use this not. Let's do this as well. I'm going to say can one. So now I have two cans. So these cans both have the same name and ounces because, you know, you could have two Coke cans, right? So let's kind of look at this, how we can look at two different cans. So describe. Maybe I'm describing like the Cokes on my desk. So I can test that they have same properties. So I could expect can one or can dot to equal can one. So I can take two objects and I can check. So this, notice how I changed that to to equal. I'm checking, I can check these in two different ways. I can see if they have the same properties because they both have name and ounces. Let's do another can here. Can two, let's just say this is Sprite. So now I could look at this. So these two do not equal each other because I have one can that's a Coke and one can that's a Sprite. So I could expect those not to equal each other if I wanted to get this test to pass. I could also test, you know, they are not the same can. So if I use this to be again, so I'm expecting, well, let's see what happens. If I expect can one to be can. So that fails because the to be is actually checking, are they the same object? Now you can think about this in the real world. So there's kind of those two different ways I could compare like if I have 2 cans of Coke, there's 2 different ways I can compare them. I could say, hey, like, are they both Coca-Cola classics and do they have 12 ounces? So I could say, yes, those are the same. But then I could also ask, well, are they this exact same can? And that's what this to be is checking. Is it actually the same can? Does that distinction make sense? Is the same can. So this one, I could test, I expect can dot to be can. That should be true. So we have these different matchers. Maybe I just want to check that the properties are the same. But another time I might want to check that it is the exact same object. So I have that matcher. Let's also give this one, like the Sprite can. Let's make that 24 ounces. So we have some different stuff to test. So going back to this test, we can test per can. No, it's at most 12 ounces. So I could expect my can ounces to be less than or equal to . Count 2 ounces. So I can run these tests. The Cokes on my desk, ounces per can is at most 12. Do I have a syntax error? Let's just do one of these. I think this one failed.
I think the call is to be less than or equal. It doesn't need the 2 at the end of it.
Oh, okay. Yeah, you're right. Yeah, okay. Because that one I'm expecting to pass. This one I'm expecting to fail. There we go. So this, yeah, this one, it expected something less than 12, received 24. So I can make that not to be. There's greater than, so there's greater than, or equal. So there's comparisons by numbers. There's also test, has value. Let's see if there's a to be truthy. So expect let's maybe do this just with a hard-coded values. So let's do null to be falsy. So if we're talking about truthy and falsy values, so let's just test. And maybe I would throw this. So this would be like a different, not really testing the cans anymore. So I would probably want to throw this in another describe block. We can look at truthy and falsy values. So I just throw this in another describe block. You know, this describe block is really talking about the Cokes on my desk, or I guess I have more. I should say the cans on my desk. So this describe block is really focusing on the cans. Now I'm going to do another describe block, which is us going to be looking at truthy and falsy values. So test null is falsy. So I'm expecting null to be falsy. Let's just look at some of these because these can be interesting to look at. Undefined. So undefined is falsy. Is falsy. Trying to think. Let's try to find all the falsy values in JavaScript. Is Nan? Pretty sure Nan is falsy. Not sure though. Yeah, Nan is falsy. So we have null, undefined, false. Let's look at some other things. So I could expect, you know, an empty array. Some things that you know, might be a little confusing. Are these truthy or not? Let's look at an empty array that is going to be truthy. Likewise, like an empty object. That would be truthy. Oh wait, I know there's, okay, let's test another one. I would test, I think 0 should be falsy. Zero is falsy, but let's like look at 1. Expect 1 to be truthy. Why is 0 falsy and 1 is truthy? Any ideas? It's really just 0. 0 is the only number that's going to have a falsy value. Anyone know why? It's really just because of binary. In binary, 0 is false and 1 is true. So 0, that's why 0 is given a falsy value in JavaScript and probably most other languages. Let's look, what else are we missing? There's, oh wait, we have null, undefined, false, Nan, 0. What about an empty string? I can't remember if this one's falsy or truthy. So an empty string is falsy. We have something in there that's truthy. So there, you know, we can test truthy or falsy values, but I think, you know, it's easier to kind of just remember the falsy values because everything else is kind of considered truthy. So null, undefined, false, Nan, 0, and an empty string. I think there's like some other ones that are like kind of different versions of 0. N, is that a big number? Do that. How do I do? Let num equal a big int 0. So you could have like a number as a big int, but it's still just 0. Cool. Let's see, what else do we have? And let me just also show, so with something like jest, jest is a pretty big library. A lot you can do with it. So yeah, if we look at some matchers, just since we kind of have an idea of how matchers work, you know, these are some of the matchers we have. So we could test null, you know, we could expect it to be null, to be defined, not to be defined. So these ones are kind of interesting. So you can look at like null. Null is null. Null is actually defined. It's falsy. You could also look at 0. 0 is, you know, not 0 is not null. It's defined and it's falsy. So we have ways to compare numbers that we looked at. Ways to check strings. So we can once again, like this one, there is no I in team. So we could expect team to not match this regular expression. Or we could match, you know, there is a stop in Christopher. Expect Christopher not to match stop. We can do things with lists. So let's say we have an array of, we can just kind of throw this in our Slack or in our code. I'll throw this in Slack too. This can be like the iterator ones. These can be like very useful too. You know, you could have an array of, you know, objects or items, and you could see that it contains milk, or you could create a new set and see that that contains milk. We looked at exceptions, so we can have our code throw exceptions. And this is, there's really quite a bit of expect methods and matchers. So you can expect, you know, a method to be called a certain amount of times. You can expect the method to have been called, to have returned, to be falsy, to be defined. So here's a lot of these matches. And then there's, you know, this documentation on how to use these. And this is why we use jest instead of like at the start when I was just trying to write my own functions. Like it has all of this, all of these expect and these matchers to come in. So, let's just look at one other thing and then we'll take a break. So you can have these callbacks before like you run your tests. So you can do like a before each and after each callback. So I'm just going to throw these up here. I'm just going to do a console.log. Before each callback called. After each callback called. Where did that? Oh, I need to get rid of that function because I don't have it. So I can run these functions before each test, and then I can run a callback to run after each test. So yeah, you might want to do something like initialize a database or clear database, or like reset your test, like reset your objects, because maybe in your test, you come in here and you change your can. To equal 24. And then in your test, you can say like count, like after each test, let's like reset my count ounces to equal 12. So it gives you time to like set up before each test and to clean up after each test. So then in your test, you can change stuff, but then you can expect it to kind of revert back to the way you set it up for this after each. There's also one-time setup. So there's a before all and after all callbacks. Do console.log just to see this callback being called. Before all called. You know, console.log. So that after all call is called at the very end. Then we have those before and after getting called on each of the functions. But that before all is called right at the start. But it's only called once, just right at the start. And then that after all is called just once right at the end. Cool. And you can also scope these to the describe blocks. So for instance, I could do I could do it before all. So these can be scoped to these describe blocks, because maybe I want to do some setup for just this block of code. So we'll see somewhere in here. Where's the can? So before all called. So now I'm running the can before all called. So now it's doing all the can tests. And then there's the can after all called. So you can scope these callbacks to these functions. Cool. So yeah, that's just a little taste of testing. Let's take a break. When we get back from our break, I kind of want to talk about what we're going to be doing tomorrow as far as the manual testing. So, if we're looking at, what we're talking about today, Jest is like a unit testing library. We can use Jest to kind of work up to integration testing and use Jest with other libraries to do some more end-to-end, but specifically today, We're talking about unit testing, but when we get back, we're going to talk more about this manual testing. And that's what you're going to be doing tomorrow. So let's take a break. Let's just come back at 12:15 and we'll go from there. And I will Slack out this code right here. Okay. So yeah, the last part of the lecture today, I just kind of go over what you're going to be doing tomorrow. Now, normally I would have done this tomorrow, but Nee's going to give a LinkedIn presentation tomorrow. So I want to give you a little more time to test apps. So we'll just talk about this now. And this Neo notes is in the QA section of Friday lectures. So if you want to look there, but yeah, so tomorrow you're going to be manually testing each other's apps. And, you know, we talked about this already today. I'd say there's two general flavors of testing, and that's automated and manual testing. So with something like Just that we just looked at, that's automated testing. Like we can write those tests once and then we run yarn test and it runs those tests. That's why it's automated. It automatically does it. So tomorrow you're going to be doing manual testing, but you know, there's pros and cons to both. And we looked at that graph that, you know, kind of looked at unit testing, integration testing, and end-to-end testing, where the further we get to like end-to-end testing, that's where we're testing like a whole flow, a whole feature. And, you know, that gets a little harder to automate. Unit testing, we're just testing an individual or the small parts of our app, and that's easy to automate. And then there's kind of like a middle ground of integration tests where you're combining smaller parts to do that. So, and just like an example, like maybe that might be unit testing that we've done is like when we go to Postman to ensure that we're getting back some data. Because, you know, that's kind of testing like our controllers, our routes, our model. You know, it's not maybe not the whole feature of logging into your site and grabbing the data, but it's you know, there's a lot of pieces when we're checking a Postman, like an API call. There's some other testing terms to kind of just keep in the back of your mind. Smoke tests. This might be like a set of basic tests that test like the basic functionality of the app. You know, you might do smoke tests if you do like, you find a bug and you want to do a quick fix, but before you go up to production, you might run like these basic set of tests just to make sure you didn't like break anything. There's regression testing. And this is to make sure that old features aren't getting broken by new features. So yeah, when you're adding new features, you're not only going to be testing those new features, you need to be testing kind of your whole app as well, making sure those new features are not breaking anything that's just in your app. And this is another reason where testing gets pretty complicated. And yeah, you might have someone like Carlos, who's like head of like the testing, the QA team for like a project. Just a minute, because this does get, you know, quite complicated. So we're doing web apps, so we're going to kind of talk about some techniques with or some different kind of things we might test. And just to kind of once again think about how complex and, you know, how deep this could potentially go. So there's things like functionality testing. This is just to make sure your app is functional. Things like the links work on your page. You're doing validations on your inputs. You know, does it actually work? Does like your search and sort features work? Is your data coming back how you expect it? It's just pretty straightforward. Is your app functional? You could also do usability testing. This is, you know, where you're checking the flow of the app, the navigation, the controls. Is it intuitive? Does it make sense? It's kind of testing like the UX. Does it make, is it easy to use? Are there places where the user might get confused? That kind of thing. Interface testing. This can be testing all the different maybe libraries or interfaces that you're using for the app. So, with us, it's, we're combining Rails and React and Cloudinary and, maybe you're using a third-party library or like Twitter or something, or like all these different services. Maybe you have an AWS server. So it's testing, all of these different interfaces working together. Or it's the data and, the data going from one system to another. Compatibility testing. This one can be huge. This is, you would take your web app and you would test it on like a Mac, on Safari, on Chrome, on an iPhone. You would test it on different versions of operating systems, different mobile devices, iPads, Android phones, PCs, all the different versions of your different browsers. So this can get huge just because of the amount of combinations you can have of, different computers using different softwares, using different browsers, and those browsers being different versions and being on different devices. So obviously there's a huge limitation here of like how much resource do you have to test that. But it's something, if you're at a company, like, you take like a big company like Facebook, they're probably going to want to be testing on, PCs, on Macs, on older versions of, Internet Explorer, older versions of Chrome, to see that any new features that they're adding aren't breaking on specific environments. So those are always fun bugs when you get bugs that are like browser specific or operating system specific. Those can be hard to track down. They can also be very hard to find. So sometimes, you really are at the whim of the users to report it. Some other kinds of testing you might do are like performance testing. What happens if your website, gets all of a sudden 100,000 requests to it in a day? Kind of think about like the Burning Man website where you like buy tickets for Burning Man. It's probably pretty dead except for like the day the tickets go on sale, and then, they might have like 50,000 requests in just one day. So there's things like that. How is your app going to behave once it gets a lot of, use? And then there's things like security testing. So this is like, how secure is your site? And this, once again, this can be a whole nother specialty, where people are, that's what they do. They're trying to hack into your site. I knew someone who worked at like Facebook, and they were just paid to like test Facebook, and they were just essentially trying to break into Facebook and try to either, any sort of malicious attack. That's kind of what they were doing. So that can be huge kind of testing too. So tomorrow we're essentially just going to be, I would say that the functionality testing is what we're going to be doing tomorrow. We just want to make sure that the apps are working. We might be doing a little bit of usability testing. And if there might be some interface testing, just, is this stuff working with Cloudinary? That's kind of built into the functionality testing. But really, this is essentially what we're doing tomorrow. We're not going to worry. Everyone's using Chrome and we're all on Mac, so we're not going to worry about testing it on different browsers. You might want to, on your apps, just maybe go look what it looks like on like Firefox or Safari. See if you see anything different. A lot of the time with web stuff, it'll largely be UI stuff, but there can be some functional stuff that might break. But I think for what you're doing, I'd be surprised if there was anything other than UI stuff that broke. Cool. But yeah, testing is definitely, a very, can get very nuanced and in depth. So for testing tomorrow, so you're going to go in, you're going to try to break the other group's apps and find bugs. That's kind of the job as a tester. Like that's, they kind of want to break the app, or they want to find potential edge cases and, places where the app might not be working, so that bug doesn't go out into production. So when we do this though, we're going to want to be organized. So how we're going to be successful with this is we're going to organize and use tools. So I think I'm going to have us do GitHub for this one. We could use Trello. I think Trello is a good way to document bug reports, but I think we'll do it as GitHub because it will give you some, I know GitHub kind of shows like, how many pull requests you have, how many reviews you've done, how many commits you do, but it also tracks how many like issues you've done. So kind of give you a little bit of history on your GitHub for working with issues. But either way, we want to use some sort of tool to organize these reports. And, that could be Trello. Once you probably get to a company, it'll probably be Jira or GitHub. But when we write when you're writing these bug reports, you want to write detailed bug reports. You're not just going to tell the group, hey, your login didn't work. You're going to write a detailed report about what happened. So, things that might be included in a report or something like a summary. Like the price mentioned on the pricing page is not correct. Another thing you're going to list, and this is very important, is the steps to reproduce. How did you get to that bug? Because usually bugs are not just going to be, it's not just going to be like this red flashing light of like, oh, hey, you forgot your semicolon on line 3. Bugs are going to be more nuanced. They're going to like generally follow steps to reproduce. Like, oh, you have to go click on this button and then you have to enter 1, 2, 3 in this field, and then you have to click submit twice. Because far too often I have seen, if a detailed bug report's not written well or the steps are not written well, then it'll just come back and be like, oh, I couldn't reproduce that error. And you just end up wasting all of this time of someone reporting a bug and then like the developer being like, well, I can't reproduce it. I can't find it because they didn't get the correct steps to reproduce it. And it's just a lot of wasted time, which is a lot of wasted money. And the bug is still there. So as you're going through testing tomorrow, make sure you're keeping track of what you're doing so you can reproduce it. And I'm sure you probably have found that already, like where you saw a bug in one of your apps and you're just like, damn, how did I make that happen? Like it's kind of hard to reproduce. Yeah, and then you could do things kind of like we saw in Jest, like what did you expect and what did you see? Another good thing, this isn't so useful for tomorrow, but if you're really testing, you'd really want to tell them what browser you're using, what OS are you using, If it's a UI thing, maybe you bring in the screen size and that kind of thing. So you give them detailed information about your environment. And kind of going with the steps to reproduce and this thing, one of the best things you can do is, screenshots. And even better, videos. If you can have a video of you reproducing the error, that's the best because that shows the steps generally. But screenshots are good too because screenshots, it's like proof. It's like, here's the error. I'm not lying. Like I saw this error. Here's the screenshot. And especially maybe if you have a screenshot with like the console open and you can see the error message or something like that, that can be really useful too. So yeah, screenshots, logs, and videos are a tester's best proof points. So very important with the screenshots. Another thing you might do is, this is not so much about tomorrow, but this is just like testing an app. So once you have an app set up, you might create like a spreadsheet of, tests to run with each like release. So for example, this is a like spreadsheet of like, ability of like functional tests to create and edit a book. And then you can have, whether it failed or passed. So you're going to write these clear test cases, what they're doing. You can go test them. So each release, you can go through these tests and run them and say whether or not they passed. And then on the, what you're going to do on these test cases is you're just going to say what the steps are going to be for this to pass. Like this would be like, if you want to login page, checking to see that you can authenticate on Gmail, go to Gmail, enter email in the field, click next, enter password, click sign in, and then you should be going to the inbox page. That's the expected result. And this is what you would see. I had something exactly like this at Evernym. It was a spreadsheet with all the things we needed to test for us to actually release, a version of our mobile app. And each test had, instructions about what we needed to do and what we needed to see for it to pass. So communication, this just goes back to like the bug report. Like a good bug report can save time by avoiding miscommunication or need for additional communication. Like these are really important that, these are clear in what they're saying the bug is. They really do save so much time if they're nice. So another thing, and when you're testing, often it can be you just keep on testing the same case. And, as a QA person, as you're trying to break apps, look for some edge cases, kind of think outside the box a little. What can you do that? And I would say with tomorrow, it's like, don't try to get like too crazy. Don't like, don't try to be like, if someone pastes like a image or like, I don't know, they paste like 1, 2, 3 in the email field. I mean, you don't have to go too crazy tomorrow looking for edge cases, but try to think about realistic cases that when using the app that like a user might do that might break it. So yeah, and then that kind of brings us to the difference between depth and breadth testing. So depth is like you're going really deep looking for those random edge cases. But you also got to take into like really thinking of the common cases, making sure that just the core functionality of your app is there. And there's always a trade-off between depth and breadth. Like, obviously you would want both, but there's always a time constraint. So I think it's finding that balance between, making sure those core features are good and like the core use cases are tested well. But then you also, don't just get stuck on the core cases, like do spend some time thinking about some potential edge cases. And that's kind of like the testing with greater variety. Because with this type of mentality where you're testing over and over the same type of things, this can kind of lead you into, where you're kind of get a little tunnel vision and you test the same thing. So you might want to, throw in some other just random tests every now and then. Cool. So yeah, that's kind of like just what we'll be doing tomorrow. Let's just go look at like GitHub really quick, just to kind of show you what I mean by like these issues and this kind of thing. So not that it's a huge deal, like GitHub can be a little bit of a resume piece. So this was the thing I was talking about, where like you see your commits, see your code reviews, pull requests and issues. And honestly, you want to see this semi, balanced. I'm so far over with commits just because of teaching, but it's not like a huge deal, but it kind of does show, like, when you do some issues, you're kind of working, kind of doing a little bit of everything. I think employees like to see that if you're kind of using GitHub as a resume piece, just like as the same way they would probably like to see some consistent commits or consistent history. But yeah, let's just go look at issues on GitHub. So I'm sure we've seen some already. You've seen some, so I don't know. I'm going to think of a bug. Revise token auth broken. I don't know. So on any repo, you can raise an issue. And, so I'm looking at device token auth. I'm looking at their issues. I can go let's look at one that maybe has like a conversation thread. So someone could come in here and just raise an issue. I don't know how, like, this is not really documented that well, but anyone can raise an issue on any repo. So then you can like upvote it, and then there can be a thread associated with that. Likewise, you can add images. Let's see if we can see a better. Like, here's a good example of a issue. So they're giving the version environment info. So they're going to say, hey, what version of device they're using, what version of Rails, maybe some other things. Here's a little like a synopsis of what's going on. They're explaining what's happening. They're sending some images and expected and actual results. So this is kind of like the thing you would want to do if you're opening up an issue. And this is what we're going to have you do when you open up an issue for, the other group. So I could just go to like my repositories. Let's pick a random one. I could go to issues. How does this have so many issues? Oh, this is for all. Oh, that's all my issues. Okay. So how does that one repo have so many issues? Because I select the global ones. I could come in here, issues, and I can create a new issue. So yeah, I would leave a here, and this is what you're going to do tomorrow. You're going to leave a description. Like let's call it a summary. You know, what is the bug? And like the steps to reproduce. How did you find the bug? And then images or like a screenshot would be nice if needed. And for the screenshot, we can just drag and drop files in here. So where is an image? So you could, I'm not going to do it, but you can just drag and drop an image in here. And if needed, like I think this is all like what you think you needed, expected and actual. Because sometimes you might report a bug and it's really not a bug. And it might be more of like a usability thing where you got confused as a user, which, you know, in a way is a bug, but they might need to go change the UI. So you come in and then you could fill that all out. Why does this not let me submit? Oh, I need a, so you could be like a, you know, button not working. So this would be like the name of the bug. So, but then you would leave the summary, steps to reproduce, screenshots, needed, expected, and actual. And then you could submit that issue. Another thing you could do to get this up with Trello, so you could use both. You know, where is Trello board? You know, you could still connect this with your Trello board, and I think you should, just so you can see them. Is you could create a card for this. And then in the card, throw the link to the issue. And then you can, you know, maybe label this as, you could create a label for bugs. So then anything that's like red or purple, you know, would be a bug. So then that way it can still be on your Trello, but all of the information about the bug can be on the GitHub. And then that way you can clarify, like, with whoever created the bug report. And then once you like fix the issue, you could also, because you can like link this to a pull request. I would need to create a pull request, but I could, you know, if I had a pull request, I could link this to that pull request that I made, and then I could close the issue. And then it kind of had that history of being linked to that specific pull request where we fixed the bug. Then I closed this issue, and now it's marked as closed. But that history of it's still there if I ever need to go back to it. Cool. Are there any questions on this? Sweet. With that, we'll just leave it on a joke. I like this. It's kind of like when we're talking about QA and like testing and edge cases, it's kind of like this joke right here. Like a QA engineer walks into a bar, orders a beer, orders 0 beers, orders 9 trillion beers, orders a lizard, orders -1 beers, orders a blah, blah, blah. And then first real customer walks in and asks where the bathroom is. The bar bursts into flames, killing everyone. So that is, I think this is testing in a nutshell. So we can try to test as much as we want, and it's good, but it's really hard to, test all this stuff. Sometimes we get focused with testing all these edge cases that we can't think of, like, what's that realistic edge case that we didn't think about? Cool. Well, I think that is it for me. We'll do a quick review tomorrow just before you get into testing about like the GitHub stuff. And then, yeah, I'll be around then. So I believe that is it. So we can we can hop off. Yeah, let's just come back. Let's just come back at 2. And yeah, it might even be a good idea today if you could push your apps up to Heroku. You don't have to, like the other group can just clone down your repo and test that way. But if it was up on Heroku, then that's a way you could get them to test on Heroku. So if you have time, that might be something you want to do today. Cool. Well, we'll see y'all at 2 o'clock. Have a good lunch.
See you. Have a good lunch.